This video is going to give you a good definition of what exponent numbers are, right? So like 2 squared or 3 cubed or 12 squared, right? What happens when that power, that exponent up there, right? We've got that base and we've got that power. What happens when the power is 1? And what happens when the power is 0? It's a little bit weird, but it's really easy to remember. The first thing you should do is copy down these rules. They will help you. They will make your life a lot easier. I usually hate rules, but these rules are really useful. Any exponent with a power of 1 is equal to the base. So let's look at these examples, right? We've got 5, that's the base, and up here is the power. This is the base. So any exponent with a power of 1, well, do we have a power of 1? Yeah, we do. Ding, 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 right up here with a power of 1. So it applies to 5 over 1, right? Any exponent with a power of 1 is equal to the base. So power of 1. Oh, what's our base? 5. Okay, well, it's got to be 5. Right? So 6 to the 1, right? Well, the power is 1, so it's got to be equal to the base. That's 6. 1 to the 1, the power is 1, it's got to be equal to the base. That's 1. 0 to the 1, right? The power is 1, so it's got to be equal to the base. That's 0. Another way of writing this, if you want to write it in a little bit different words, would be to say any exponent with a power of 1 is equal to itself, right? It's equal to that number that you really associate with it, which would be 5, 6, 1, or 0. But I say to the base because I want to be specific. 5 is our base, 6 is our base, 1 is our base, 0 is our base. So any exponent with a power of 1, so we see a 1 up here, is equal to the base. Good. Now, the reason that this is true is just because we'll think about it, right? We have 5 squared. Well, if we were doing 5 squared, we would do 5 times 5. But, we say that's the amount of 5s you have. So 5 to the 1, well, it's telling you how many 5s you have. You just got 1 5. That's just going to be 5, right? You're already done. It's done for you. So let's erase this. That was just kind of an explanatory note. Let's go to our second rule. So any exponent with a power of 0, so by now we should be able to say, well, the power of the exponent is 0, the power of the exponent is 0, the power of the exponent is 0. Okay, so all of these are examples of an exponent with a power of 0 is equal to 1. All right, well, let's see. 100 to the 0. Okay, well, that's an exponent with a power of 0. It's got to be equal to 1. It's got to be equal to 1. Any exponent with a power of 0 is equal to 1. 100 to the 0, got to be 1. Let's try another example. 125 to the 0, is it to the 0? Then it's equal to 1. Equal to 1. Any exponent, 100 to the 0, 125 to the 0, 1,000 to the 0, million to the 0, 0.067 to the 0, all equal to 1. All right, let's check it out. 0 to the 0, whoa, that's a weird one. 0 to the 0, well, that's actually going to be equal to 1. That's like 2 zeros. You've got to be thinking, wow, this guy has got to be equal to 0. It's actually not. It's actually equal to 1. Weird. 12 to the 0, well, that's pretty easy at this point. It is an exponent number, and the power is equal to 0, so the whole thing has got to be equal to 1. To review, any exponent, right, any number with a base and a power, with a power of 0 is equal to 1. Any exponent with a power of 0 is equal to 1. Let's take a little look into why that happens. If you're not interested in why and you just want to move on, then feel free to stop the video. But I really think this is a cool explanation. So let's take a look at why 100 to the 0 is actually equal to 1. And in fact, why 0 to the 0 is actually equal to 1. Well, let's think about it. Let's look at 100 to the 3rd. Right? That would be equal to 100 times 100 times 100. Okay, well, we calculate that out, but that's not really what I'm interested in. I'm interested in saying, okay, well, what is the relationship between 100 to the third and 100 squared? And what you find is that 100 squared is actually equal to 100 to the third divided by 100. And let's see what that looks like. Well, 100 times 100 times 100, well, that's going to be equal to, well, we've got this numerator, right? So we just expanded out this 100 to the third to 100 times 100 to 100, and now we got a 100 on the bottom. Well, we can just cross this out, just like that, right? We're just multiplying, so we can just cross out, and we get equal to 100 times 100, which is actually equal to 100 squared, which is what we wanted in the beginning. 100 squared, well, that's equal to 100 to the third over 100. We crossed out, we got to 100 squared, so it all works out. Let's go another level. We get 100 to the 1, and we know that's got to just be equal to 100 from our work up here. Well, that's going to be equal to 100 squared over 100, which is equal to 100 times 100 over 100. Cross it out, and it's just equal to 100, which we knew 100 to the 1 was equal to in the first place. So let's do it again, right? We're going to be able to divide 100 to the 1 by 100. So we move down, we say 100 to the 0 is going to be equal to, well, it's equal to 100 to the 1 over 100. Well, that's just equal to 100 over 100. And 100 over 100, well, that's equal to 1. So that was a bit of a conceptual explanation. You can take these notes down and ponder them for your own convenience. But the real important takeaways from this video are that any exponent with a power of 1, so you see a 1 up here, got to be equal to the base. Got to be equal to the number down below. Any exponent with a power of 0 equal to 1. And I found it very, very fun to play around with these lines of math and just see how it sort of starts to make sense to me as a kind of proof in the way things are going.